Okay, so in this little short video, I'm going to just talk about the most common, most used estimate of price sensitivity, and that is going to be elasticity. Elasticity. This is a measure that we're going to talk about extensively in this course. They show you a couple other measures in your textbook, namely a slope measure, which is you might use for just like some back of the napkin kind of calculations. And they also have a hazard rate, which I'm not going to just dive into. Elasticity is sufficient. It is by far the most used, and so that's one we're going to focus on. And you can largely kind of ignore the others because I'm not going to hold you responsible for that. And there's enough to talk about elasticity to keep us busy for years. So let's focus on that. Okay, so price elasticity of demand. I have to give you a little word of caution. So in your book, I want to show you we have they start off by giving you price elasticity, and they come up with this kind of form right here between two price changes, and we get what's called an arc elasticity of demand. That's not the measure we're going to use, okay? That's not the measure we're going to use at all. Look, remember our price response function, this D function, D of P, takes a price and returns a quantity. That's actually something that we don't really quite know. Remember, that's theoretical. Now, we can observe quantities. So if you have two prices, you have two quantities, you can estimate an arc elasticity if that's all that you have. And there may be some value in that. Like if you just need this is kind of like back of the napkin kinds of calculations. If you want to just kind of quickly jot down some things and figure it out, you can use arc elasticity to do so. You should know that. I could ask you to calculate it. Maybe, I don't know. Should I? It's just another thing. And I don't think it's that complicated to figure out. I mean, this is just a formula. Look, this is D of P2 is just the quantity at price 2. So you have here you have two different price points, P1 and P2, corresponding to two different quantities. This D of P1 and D of. So literally, if you just have price and quantity data on 2 points, you can put it in here and work out an arc elasticity and just call it a day and get some kind of back of the napkin kinds of calculations. But you better be taking this with a grain of salt, and you better not hang your hat on the results as being something. If it's really critical, this is not the way you want to go. So I'm not going to just dive into this way. This is back of the napkin kinds of calculations that you would see in undergraduate textbooks. That's fine there. We're going to skip it here. You should know, though, that price elasticity is going to be defined more formally in the following page. So equation 3.8 is a more formal definition of elasticity that you do need to know. And unfortunately, I said calculus is not required in this class, and they've given it to you in with a derivative. This D prime is a derivative. So I need to spend a minute and just demystify this just a little bit for those of you who don't have calculus. So let's dive in. Elasticity, I'm going to give you, is going to be actually just defined as a percentage change in quantity for a percentage change in price. Okay, that's what it is. That's the definition. That's how we should always be, and it's just about how we're gonna write it, how we're gonna estimate it. It depends a lot on a lot of things. We're gonna dive into it, but here we go. Percentage change in quantity. Remember, quantity in this book, to stay true to the notational form of the book, this will be a percentage change in our price response function, D of P, with respect to a percentage change in P. Okay, and if you know something about derivatives, you know that first off, you know that you know we're not talking about derivatives talk about change. We're talking about percentage change. That's a key difference between this and just a straight derivative. Okay, so look, what does your book have? Your book gives you an elasticity. P is going to be in your. This is your text. This is equation 3.1. They give you D prime of P, and then P over D of P. That's what they give you. Okay, so I just want to show you something. Look, D prime of P. for those of you who don't know calculus, this can be rewritten as the derivative of p, which I'm going to call delta to keep on our notation. It's really talk about the change of quantity with respect to the change in price. That's what the derivative is, okay? So this portion is the derivative right there, okay? And then I just rewrite the rest of the equation, p over d of p. This together will be, got Christmas colors, our functional form. Again, it's going to be this change of d of p with respect to p times p over d of p, which is just the change in quantity over the change in price for a change in price times the price over the quantity. That's going to be our definition that we're going to lean on throughout the rest of our exercises. Okay, so I'm going to show you in the next. If this looks a little bit confusing, don't worry too much. Let me just demystify this a little bit further. I'm gonna hit this point home in a couple. You probably hear some of this repetitively. So, but here we go. I'm going to show you our price response function just to show you where this derivative is coming from, what it looks like. This is our quantity. Remember, with price, we have a price response function. Okay, that's out of your text. And look, it's the change in d of p over change in p. That really, look at that. That's really the slope of a linear price of this price response function. That's actually the slope of the price response function, not just linear. So it's the change. Here's the rise, the change in the d of p over the change in p. Remember, it's rise over run. There we go. Slope of your price response function times p over d of p. Okay, that's what we got there. That's it. So that's the elasticity calculation to give you clarification of 3.8. That's equation 3.8 in your text.